Alright guys, I want us to now look at calculating compound interest. Compound interest is a little different from simple interest in the fact that it's interest computed on the original principal as well as any interest that has been accumulated along the way. And the formula for calculating the amount in an account for compound interest that's paid in times per year is your future value, A, is equal to your principal amount times 1 plus R, which again is your rate, over N, the number of times it's paid a year, raised to the N times T. Okay, so that's our formula. Again, A is your future value, P is your principal, R is your rate, T is your time, and N is how many times per year that's going to be paid. And so we're just going to plug in for what we have. So my A equals my principal amount, which in this case is $12,000, times 1 plus R over N. Okay, so now remember, R is your rate, but when we look at a rate, we have to turn it into a decimal. So that's 1 plus 0.04 over N. Well, we're compounding annually, so annually means once a year, so my N is 1. And then we're going to raise that to, again, the 1 times 5, because my time is 5 years. Alright, now it's just a matter of simplifying this up. So we have A equals 12,000 times 1.04 raised to the 5th power. Now there's a couple of different ways that you could punch this in, so it's up to you how you want to do it. What I would do is I would do the 1.04, raise that to the 5th power first, and then I would take that and multiply that to the 12,000. Okay, and so if we multiply all this together, we get A equals 14,599.83. Again, you want to make sure, because we're talking about money, when we round, we always round to the hundredths place value, or the nearest cent place value. So 14,599.83. Now question B says, okay, well, how much interest was accumulated or earned during that time? And so in order to find the interest, we need to do the principal subtracted from the future value. So we're going to do $14,599.83 minus our principal amount, which is 12,000, and that gives me a total of, let's see, $2,599.83. And so that would be the amount of interest earned. Alright, let's look at another one. This one says our principal amount is $6,000, my rate is 3%. This time we're going to compound it quarterly, which means it's going to be paid 4 times per year, and we're going to do this over 4 years. Alright, so again, we're just going to plug into our formula, which is P times 1 plus R over N raised to the N times T. Okay, so if we plug in, we have A equals my principal amount, which is 6,000, times 1 plus 0.03 over 4 raised to the 4 times T, which in this case is also 4. Okay, so again, N in this case was how many times it was compounded per year, which quarterly is 4 times per year. And so now again, we just want to start simplifying this guy up the best we can. So we have A equals 6,000 times. Now, the way I would do this, I would do my 0.03 divided by 4 first, and then add 1 to that. Okay, so do your 0.03, divide that by 4, and then add 1 to that value. And now when you do that, in this case you get 1.0075. So 1.0075. And now that's raised to 4 times 4, which is 16 to the 16th power. Okay, so now what we're going to do is we're going to finish calculating this out. So raise that 1.005 to the 16th, and then we multiply that value. Okay, so we're going to 1.0075 raised to the 16th power, and then don't even clear it from your calculator. Just go ahead and immediately hit times and punch in that 6,000. And then again, make sure you round to the nearest cent. So we get A equals $6,761.95. So that's our future value amount. And that's part A. Question B now says, find the interest. Well, again, interest is your future value amount, so $6,761.95 minus the principal amount, which is $6,000, and that's going to give me $761.95, and that was the amount of interest earned during this period. Alright, let's look at this last problem, an application problem of compound interest. It says at the time of her grandson's birth, a grandmother deposits $5,000 in an account that pays 7% compounded monthly. What will the value of the account at the child's 21st birthday, assuming that no other deposits or withdrawals are made during this period? Again, so we're looking for that future value, so we're looking for the A. And we know that P in this case is 5,000. And then times 1 plus R over N. Well, R is 7%, so 0.07 N. Okay, now it's compounded monthly. So there's 12 months in a year, so then my N is 12. And then we got to figure out our T. Well, the birth to 21st birthday, so my T will be 21 years. Alright, so that's just us plugging it in. Alright, now we're going to go through and we're going to simplify this up a little bit. Okay, so we have A equals 5,000 times 1 plus 0.07 over 12. 12 times 21 is 252. Now what I'm going to do is I'm just going to put this in my calculator exactly how it appears here. I'm going to first do the 1 plus 0.07, divide that by 12, and I'm going to take that value and I'm immediately going to raise it to 252 and get that answer, and then I'm going to turn around and multiply that by 5,000. So kind of working backwards here. And when we do that, we get a future value of $21,653, and again we're rounding it to the nearest cent, so that gives me 50 cents. Alright, so that's my future value. Okay, so again, the way I got that was I took my calculator, I did the 0.07 divided by 12 first, found that value, added it to 1, got that answer, immediately raised that to the 252nd power, got that answer, and then multiplied it by the 5,000 to get the $21,653 and $50. So just make sure, it's just a matter of plugging in, being able to pick out your P, your R, your N, and your T, and then just plugging them in into the formula and being able to simplify it.